Hello and welcome to the Bearded Math Man's YouTube channel. Hey, in this video, we're going to be talking about our radians. By the time you're done, you should know what radians are. You should know how they're different from degrees. You should know how to convert between degrees, radians, radians, degrees for any angle, and perhaps most usefully, you should come away with an excellent understanding of how to get all of these angles written in radians without having to memorize it. So you're going to really understand it. That way you can just spit it out just like you know your multiplication tables. So let's get into it. Now, I'm going to ask you a question because in order to answer this question, you need to think about some things that are really important towards what radians are. So let's say we had a circle and we knew the circle's radius. If you were going to take that radius, the distance of that radius, and start to wrap it around the edge of the circle, how many times would it take before you could circumnavigate this circle with this distance? So in other words, how many radii, as plural for radius, would fit? Starting here, wrapping all the way around on the circumference, how many would fit? So we're going to get into that in just a minute. I'd like you to kind of think about it for a second. Let's talk about some definitions of what radians really are. Radians are the unit of measure internationally for angles, like meters, kilograms, seconds. Some we use here in the US, some we don't. Degrees are used everywhere, but radians are used as well. That's the international standard. So radians are often written as an international number with pi, and there are 2 pi radians in one full rotation. So radians, though, different than degrees because they are very much related to the length of the radius. So now let's go back to our question. Did you get it? Did you know? Did you figure it out? Well, here's the clue. The distance around the edge of the circle, that's called the circumference. The way we find the circumference, right, is 2 times pi times r. Pi is a number, 3.14. It actually comes from a circle's circumference divided by the diameter. That's where pi comes from. But this is the distance of the circumference for any circle, 2 times pi times the radius. So that means that the circumference is 2 times pi times the radius. So it takes 2 pi radii to go all the way around the edge of the circle. So a radian is the rotation around the edge of the circumference that would be measured by 1 radius. That would be what 1 radian is. So here in this diagram, we see 3 radians. It's almost half of a circle. In fact, it would take pi radians to go 180 degrees. So to go all the way around the circle would be 2 pi radians. So 1 full rotation, 2 pi radians, or 360 degrees. So we've talked about what radians are and how they're different from degrees. Do you really understand that? If you're studying this, maybe for the first time, it might be a good idea to pause the video, write those things down. So a radian is the rotation around the circumference measured by the distance of the radius along the circumference, and there are 2 pi radians and 360 degrees. Now, let's talk about converting between the different kinds of units, between degrees and radians. So here's our key fact. 2 pi radians is 360 degrees. So I'll go ahead and set this up for you. If you're converting from radians to degrees, well, then you would want to start off with this proportion. 360 over 2 pi is equal to however many degrees you need divided by how many radians you have. So that's what you would use. Whereas we would use the reciprocal of that if we knew the number of degrees and we wanted to convert that into radians. So this always works. There are other ways to go about it, but this is pretty easy to remember. Just set up your ratio of degrees to radians, put your unknown value in the numerator, and go ahead and set it up a proportion and solve it. So let's see an example. Let's convert pi over 3 radians into degrees. So pi over 3 radians, that would be 1/3 of the radius wrapped around the circumference. That's kind of a weird idea. We don't think about degrees that way at all. But let's go ahead and set this up. So 360 divided by 2 pi, that's our ratio, is equal to how many degrees compared to pi over 3. So to solve this, you would multiply both sides by pi over 3. You do have to do a little bit of arithmetic. You have to reduce. Most of the time, we're going to use pi and we're going to leave our numbers as irrational numbers. So we're not going to plug this into a calculator, but what we have here is pi reduces with pi, right? That makes 6. 6 goes into 360 60 times. So pi over 3 radians is the same as 60 degrees. Now, if we were going to do a similar problem, but change from degrees into radians, we would just use the reciprocal of that proportion. So 2 pi over 360 is how many radians compared to 45 degrees. Multiply both sides by 45 degrees, reduce, and there you go. Pi over 4 radians is 45 degrees. Now, do you understand how to convert between degrees to radians and radians to degrees? I hope so. If you're learning for the first time, once again, I think it would be a good idea to pause the video, go ahead and write down these ratios, maybe try a couple on your own, see if you're ready. Now, last thing we're going to talk about, the shortcut. So there's going to be some interesting ways we're going to count and reduce that's going to help us understand how that unit circle works. The only thing you really have to know is the angles that are on a unit circle. So if we take a unit circle and we look at it, all of these coordinates, they're side lengths of triangles, right? And these are degrees. So here's 0 degrees, and it's the same as 360, and then 30, 45, 60, and they're all multiples of 30, 45, and 60 degrees. All of the angles are. So if we started off with the first one, 30 degrees, right? It's right there. And so how many 30-degree angles would fit inside of one circle? Well, to figure that out, wouldn't you just divide 360 by 30? You get 12. 12 times you could write a non-overlapping 30-degree angle inside a circle before you made a full rotation. So you could rotate 30 degrees and 30 degrees 12 times. So let's go ahead and take a look at what that's going to look like. And you're going to see why counting this way is going to help you to translate from degrees to radians, so that if you had to fill out a unit circle without any sort of notes or a calculator, you could do so probably in less than 2 minutes. All right. Now, would you agree that if this is 30 degrees, that's one 30-degree angle? Now, the next angle is 60 degrees. The next multiple of 30 is 60 degrees. Well, that's really 2 30-degree angles, right? And then we have 3 30-degree angles. That's, of course, 90. And then 4 30-degree angles, 5, 6, 7, 8, 9, 10, all the way around until you get to 12 30-degree angles, all the way around. Now, we're super familiar with, what 90 degrees is. We never think of 90 degrees, or rarely think of 90 degrees as 3 times 30, but that's 90 degrees. That's 120, 150. We're familiar with these kinds of numbers, so we never think about it as multiples of 30 degrees. At least very rarely. It's not a very natural thing to do. But do you see that if you have 150 degrees, what you really have is you have 5 30-degree angles. All right, now, let's see if we can make this make sense for radians. All right, so here's what we know. We know that if you had a full circle and you did 30-degree increments of rotation, it would take 12 of those angles to make 360 degrees. We also know that 2 pi is also a full circle. So what happens if you divide 2 pi by 12? Because that's going to be the same exact amount of rotation as 30 degrees, but in radians. So 2 pi divided by 12, all you got to do is reduce that. You end up with pi over 6. So 30 degrees is the same as pi over 6. Here's one of them. This would be 2 rotations of pi over 6. This would be 3 rotations of pi over 6. This would be 4 rotations of pi over 6, and then 5 rotations of pi over 6, 6, 7, 8, 9, 10, 11, and 12, until you went all the way around the entire circle. Do you see? So each one of these 30-degree angles is the same as pi over 6, and we have 12 of them to make a full circle. Now, just like we wouldn't write, we wouldn't write 4 times 30 degrees, we also wouldn't just leave 4 times pi over 6, because that can be reduced. So we need to go through and clean these up. We wouldn't write 1 times pi over 6, just pi over 6, right? 2 times pi over 6, that reduces to pi over 3. 3 over 6, that's a half. This is going to be root 2 over 3, and all the way around, all of those fractions just get reduced, and that's how we end up with these radians. Do you see? No problems right there. All right, now, what about the 45-degree angles? Well, how many 45-degree angles fit in a full circle? Let's see, we have 1, 2, 3, 4, 5, 6, 7, and 8. Now, the thing people always mess up when they're counting, they say 45, they go to the next blank, and they skipped one. This is a multiple of 45. 90 is. So there's 1, 2, 3, 4, 5, 6, 7, and 8. So 360 divided by 45 is 8. So if we want to figure out how many radians is 45 degrees, we would divide that 2 pi by 8, and we get pi over 4. So 45 degrees is the same as pi over 4 radians. So this is 1 pi over 4, and that's 90 degrees is 2 pi over 4. And then 3 pi over 4, 4 pi over 4, 5 pi over 4, 6, 7, and 8 pi over 4. All you got to do is go through and just reduce those. And it turns out that the ones that reduce, well, we already know those. 8 pi over 4 is 2 pi. 2 times pi over 4, well, that's pi over 2. Do you see? So we have 1, 2, 3, 4, 5, 6, 7, and 8 pi over 4. Those are multiples of 45 degrees. And now we know what all of the angles are for the unit circle. All right. So now, question is, what do you need to remember in order to reconstruct that understanding, say, if you were taking a quiz? I think all you've got to do is convert 30 degrees into radians, or just remember that 30 degrees is pi over 6, and that 45 degrees is pi over 4, and then you just count them off. Boom, you're done. Now, what do you have to remember to convert between radians and degrees? I think you just have to remember that there are 360 degrees in a full circle, just as there are 2 pi radians in a full circle. If you set up your ratio, and then from that you set up a proportion, all you got to do is solve it and you're done. All right. Now, of course, in order to be proficient at something and to remember it, you need to practice it and test your understanding. So there's some problems right here. I'll put a link in the description below to my website, thebeardedmathman.com. You can go there. You can read some more in-depth detail about radians, where they come from, how to convert, all those kinds of things. You're going to have some practice problems. There's going to be some blank unit circles you can print off and try to fill out just from memory or thinking. Hey, if this video has been helpful, give it a thumbs up. Hey, subscribe. It's free. What's to lose, right? And please share it on social media. Also, hey, give me a comment. Let me know if this was helpful, if it was useful, if you're confused. I'd love to hear from you. Until next time, I hope you have a great day.